There we go. I have pressed the button. Okay, we didn't finish 1-1 yesterday, but we never did a daily quiz on 0-8 because Frank was being dumber than dumb. So, since we don't have a quiz for 1-1, we did not finish it, we'll take the opportunity to go back and do that 0-8 daily quiz that we should have done if Frank was not a flaming dumpster fire. Okay, so we'll go back and take care of this one. That means today we're going to finish 1-1, go straight into 1-2. When you come tomorrow, you'll do the 1-1 daily quiz. Okay? It doesn't have to be a set, do it this way. It's just a little gut check about, hey, do you remember how to do this? Yes, ma'am?
Can I have some help with my calculator?
Maybe.
How do I add stuff?
Because you're in the wrong place. Staff. Edit. All right. I'll take care of that. No one burned anything. Natalie's in charge.
Dude. This is not flawed. I don't even know why you're not keep that during your second. They're the second why you use Zoom staff. Bless you.
Let's see.
Anyone else having issues with the new laptops being slow?
Yes.
I think they cheaped out and got something with a slower processor in it. Now, will you stay there is the question. Okay, cool. What is this? Cool. Anyone still going?
Yeah.
Hey.
If we're gone, do we wake up daily quizzes?
Yeah. Same. Daily work. You just watch the video. It's on there.
Oh,
This is on the video right now. Start the video. Do the thing. Pause it. Do the thing for real. Go look at the answer. Grade it. Okay. Low stress. Okay. Said I'm not concerned about these. I know that there's always going to be kids who are dishonest about it. I know there's kids who won't do anything and then just write down what I have on the board. Not as much in pre-calc as you get in lower grades, but y'all, you do that, those quizzes ain't going to look too good. That's always awkward conversation with mom and dad. They got 90s and 100s and everything. Why do they have a C in your class? But not. I get pretty worked up and I'm like, oh hey, the part where they actually have to know what they're doing. and they're fully supported with open notes, that's what they're doing trash on. Awkward. Okay, I got a bunch of data. What do I do with data? Plug it in, plug it in. What the? Frank, you cross-eyed Alabama son of... Yeah, we got to give it time to remember, oh, wait, that's right, I'm supposed to be over here. That's why I was asking. Like, y'all are having problems with your laptops too? Like, they're slower than last year?
Yeah, I was trying to do no red ink last night for my shares class, and it wouldn't even let me type in the boxes on there.
Yeah. Now, I was hoping that part of the problem was the port. The port replicator, the box that we have, is for the old computers. I was hoping when we got the new docking stations, it'd fix my problem up here. But if you're having problems with just the laptop, what is it? Who? What? Um, I don't know. Other than because the window's maximized, I would say it's just the background because my background is yellow. Yellow's inverse of blue. I would say that the window was too small, but the window's maximized. So I think it's because we got trash laptops. But now I will. Don't. No. 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 I pressed the button. Don't you give me that crap. Frank, I'm gonna beat your head. Turn your phones off before you get to class.
I love that ringtone. Oh, I have a screen mode on my watch.
All right. You. Go away. You. All right. Don't start with me.
Dude, we can do walkie-talkies in that. Oh, Paul, turn on your
It
walkie-talkie.
calls me dad.
No one's supposed to be Spider-Man.
It's on.
No, but I'm like, I'm it's like dad.
I watch close to
Let's try this again.
I just added Yes. I think I added
My smartboard's as old as you.
Well, then whatever you say, like,
Are we gonna have to turn the room?
I think we're gonna have to turn the room.
Stupid Frank. Why?
Stupid Frank. All right. All right. It was writing, right? Okay. It writes. It's just not registering the calculator. Okay. All right. If it's just not registering the calculator, I can work around that. I'll hate it and I'll complain about it a lot, but I can work around it. All right. I'm pressing buttons on the calculator and nothing's happening. Okay, so stat, edit. Our numbers. What were the first ones? 369, 398. Okay, now you're not even going to do those.
You can just use my calculator and just tell us.
Oh my God, Frank, just die already. Okay, you put data in.
Get a USB fryer. Stick it in there.
Break it.
Break it.
Don't tempt him, he might actually do it.
He's thinking about it.
Just throw a kid at it. It'll break. Covering the mic.
If a student was to accidentally stumble and fall into it very violently, therefore breaking my board, I would have to get a new one to replace it, right? Accidents are accidents, you know?
I can trip on my Birkenstock.
There you go.
Paul just walked past you.
All right. This is such trash. I can do this faster on a scientific calculator than I can on a free. Okay. So, staff thing 369, 398, 381, 392, 406, 413, 006, 376, 454, 420, and 335. Okay. You go find your one variable stats, blah, blah, blah. Okay, if it'll at least write, that's what I need. Measures of central tendency, I see. Assuming that my fat fingers did not do this wrong, I got about 399.4. Okay. We have a standard deviation down at our measures of central tendency around 23.89. Did anyone use the 25.18? Okay. I had someone ask that question the other day, and I should have stated this. When you do the one variable stats, it's going to give both the population standard deviation and the sample. We're always going to run with the sample because it's rare that we're going to have the entire population of data. In this case, my sample is my population. It's just a difference of -1 in terms of your how many numbers there are. We're just going to run with the Words are hard, especially when you want to break things. We have a minimum at 369, a 381 quartile 1, a 395 median, a 413, so not as big, quartile 3, and a 454 maximum. Okay, so that whisker on that side should be a little bigger. What else? We had mean, median is already there. Mode, I didn't see anything repeat up there. So there's none. Range, it doesn't explicitly tell me, but 454 minus 369 is. Did anyone write down interquartile range?
32.
You don't have to, because it wasn't in the actual lesson. But if you did, that is one of our possible measures of spread. Did anyone write down variance? Good, because variance is just used to find standard deviation anyway. You literally take variance and square root to find standard deviation. So, all right. Okay, wait.
I think I typed your number wrong. My calculator is all skewed just a little bit.
381, 369. Maybe you probably just typed in.
I typed in like one wrong number, I think.
So it changed maybe your quartile is one off or something?
Yeah, it's actually quartile 3's off.
That means that one of your values in either quartile 3 or 4, you just hit the wrong button. That's all. Okay. Which means your mean would have been just a hair off of that.
398.4.
Okay. So what we're going to look for is, did you enter the data correctly?
No.
Using said data, were you able to find the measures of central tendency and spread? Even if your data was a little incorrect, were you able to find them? Then, did you have a correctly proportioned box and whisker plot that was labeled? There you go. Those will be our points. Okay.
I'll take no.
Wait, so is the daily quiz like points in the same category as like the weekly quizzes?
No.
Or not?
Weekly quizzes are the every 6th day we do quiz in class, review quiz.
Yeah, I'm talking about
That's your tests.
That Monday?
That is Monday. We review in class.
And like literally, the questions are just
Okay. Come on. Like, it's not registering a finger at all. No. What? Why? I was trying to shut down my stream instead of close a PowerPoint. All right. Dare I ask homework?
It's not concept. So you have to answer that. I know it's 36 concepts. I was like, he told us that again.
Okay.
Yeah, concept. It's not question.
Well, at least this is working. G of a thing is 2 by thing squared plus 18 thing minus 14. G of a thing is 2 by a thing squared plus 18 by a thing minus 14. G of a thing is 2 thing squared plus 18 by a thing minus 14. Okay? G of x is stuff. Go press these buttons. Meaning, G of 9 is literally plug a 9 in wherever I see an x. 9 squared is 81, by 2 is 162, plus 18 by 9 is same thing. Minus 14 is 324, minus 14 is words, 310? Okay, if I plug in a 3x, everywhere that there was an x, I put a 3x. We got to be careful that this is going to square 3. So it's 9x squared by 2. Multiply. Subtract. None of them are like terms. Leave it as is. For C, 1 plus 5m. 1 plus 5m. I know that's really tiny, but didn't leave enough room. When you square your binomial, are you okay with me squaring it and doubling on the fly? Or
Yeah.
okay. Okay. We're going to say 2 by, square the first term, square the second term. Multiply them and double, because you're going to have 2 of them. And then distribute 18 plus 90m minus 14. So it's 2 of those. So altogether, that's going to be 50 m squareds. That's going to be 20 m's with 90 m's. It's 110 m's. That's going to be 2 here. 18 here is 20 minus 14. And again, just because you can factor something out doesn't mean you actually do. If I want something simplified, I don't want parentheses, because parentheses implies there's another operation to do. Okay? Each of these were, hey, here's stuff, go plug stuff in. Yes, sir. I hate you, Frank.
Actually, no, it's just plug it in, so it's not like a.
No?
Okay, I was having a moment. Yes.
I heard 36. Same thing. Now, some of us might be able to maybe a little bit of mental math on these. If I plug a -2 in right here, -2 squared is 4 minus 4 is, square root of 0 is 3 plus 0 is just 3. Where I think some kids started getting a little iffy is when I plug a 3m in here, that's 9m squared. First of all, I don't like that they didn't put the radical first. That's it. You don't get to do anything with that. Because this is a difference, not a product. If that was just 9m squared, well, that's 9 times m. Remember, square roots are what times itself makes this thing. That's a difference. The only way that I can take that out is if I had something like 9m squared minus 4 to the 4th inside. Now it's a product. Now it's grouped together as this times this times this times this. This is a difference, which is a completely different operation than square roots. Square roots are about multiplication. So what I mean is some kids will look at this and think that they can take a 3m minus 2 out. Like, no, you just broke math. You can't take a difference out because it's supposed to be factors that come out. Okay? That's like the recipe calls for 2 cans of pumpkin, and you're like, apples are close enough. Okay? You can't just say it is because you want it to be. You can't just say that this happened because you want it to happen. That's childish. And then at the bottom, when I square this one, we're going to have 16m squared, multiply and double, so minus 16m, square, so plus 4, minus 4. Oh, I suppose, plus 3. Okay, now I can do something with this. Because cancels, you say, well, it's a difference again. What can I do with it? If I turn that into the square root of 16 by m squared minus m, now this is a product. Now those are factors. Now I can take a factor out. Now I can say the square root of 16 is 4. I can't go taking an m out. Even though I could factor an m out of here, I'd have 1m times m minus 1. Not m squared. I need square things to come out. Okay? And that's a really, really common mistake in Algebra 2. Very common. And it's something that until we pound on it for these first two chapters, we might continue to make that mistake in here. So I want to make a point of it. I'm glad someone asked it. That's why it was assigned. Because I was hoping more than a person would ask it. So, anything else? Okay. Now I'm going to keep coming over here to switch between things because that sounds like a smart board, doesn't it? That sounds like such a smart board. I'm going to just get rid of this because, oh my, no. I'll have to do linear models on the graphing calculator next hour. Meaning I can't use the friggin' thing up here. I can't use the calculator on the board, and that's the lesson we're doing. Frank, you suck. Frank. Dude.
I think you should just call the tech office, have them work on it during this period, and I just sit.
Believe me, if I had the videos from last year and I didn't just nuke my whole YouTube channel, I would have just said, press play, I'm out. I would have.
I think we should just finish one more and then just go through like.
Come on, come on, come on, come on, come on. I hate you, 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 I hate you. Like, my cursor's floating around like this is Windows 97. Like, across the screen. Oh, this is trash. State the domain of each function. If you did not write it down before, I think I said it. Not sure if I said it. We're going to want to put down our the commandments of domain. Mathocles comes down from the mountaintop and says, these are the commandments of domain. Number 1, thou shalt not divide by 0. I feel like I should like grug with the red hand paint. And they died. Okay, yes. I live in Disney Hell. Oh no, that's DreamWorks. Okay. Okay, here. Thou shalt not divide by 0. Not just square roots. Even roots. Thou shalt not take even roots of negative numbers. Bad. Something with logs. Thou shalt not take log of non-positive numbers. So that's, you can't take log of negatives and you can't take log of 0.
Okay, so just a question on two. So since so you square root something, that's an even root.
Yeah.
How is there so that's
I is how we mechanically get past this law. This is like diplomatic immunity.
okay.
I is the idea of square root of negative 1. Since it's not real, I just give it a variable to represent the idea. Remember, variables are just placeholders. They represent what you don't know. In this case, I represents an idea for a thing that we know does not exist. And then we just work with it. Like, all right, the ambassador from Kyrgyzstan has diplomatic immunity. Even though he shot someone in broad daylight, we can't touch him. We're just going to have to work with it. Okay? Like, it's an idea. You can. They can.
You get
So,
arrested.
yeah. A, if you then shot that ambassador, you would be charged with murder because you're a citizen of this country. B, it would really tick off the other country and there would be some sort of demands for sanctions or reparations.
kill somebody else with
Then that just turns into
Y'all seen in the lunchroom, like in middle school, when everyone circles up and goes, fight, 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 fight? It would be that, except with other countries. And number 4, we don't know yet. Okay. Here, this would be like,
We're gonna just be like, huh?
Coming soon.
okay.
Coming with you.
This would be like the teaser trailer. All right. Chapter 4. So, when I look at each of these, I have to think for domain. Domain is asking who's not allowed to the party. Okay? Pretty much everyone has at some point been on the receiving end of, you're not allowed to my birthday party. You can come to my party. Oh, you get that kid who's, oh wait, no, it's not the 90s anymore.
Pretty much your parents made you.
No.
Someone sends out the invite, right? So what's the modern equivalent of handing out the flyers party at my house this weekend? Okay, just throw it on your story and then put at the bottom. Not him. Nope.
No, you just block them from your story.
Oh, okay. There you go. So you've got this idea of everyone's allowed to my party except this kid. Like, seriously, do you remember what he did last time? No, you ain't coming back. My dog still ain't right. Okay?
Whoa.
Okay, y'all taking this wrong. Don't feed dogs chocolate.
Oh, gotcha.
Where are you going with this? You whole bunch of perverts. Jesus. Teenagers these days, y'all a bunch of like nasties, dude. Okay. I'm looking at these and saying, who up here is about to break what law? Okay. If I see this, does it have a variable on a denominator? Yeah. So it's about to break law number 1. Does it have an even radical? Does it have a logarithm? So if it doesn't have an even radical or a logarithm, I only need to worry about how am I going to break law number 1? Those are the people that aren't allowed at my house. I'm not allowed to divide by 0, so I'll set my denominator equal to 0. And say, the things that make my denominator 0, the things that will break the law, are 0 and 7. So they're not allowed to my party. And to write the domain that specifically excludes this kid and that kid, we're going to use our interval notation that says from negative infinity to 0, can't touch it. And then 0 to 7, can't touch it. And then 7 to infinity. You see how the parentheses, they get as close as possible to 0 and 7 without saying 0 and 7. So maybe you put in your description that if you have ever dated my sister, you're not allowed to come here. And there's only one person who's ever dated your sister. You said it without saying it, right? Okay? I said it without saying it. 0's not allowed. Because I put those little butt cheeks on 0 and said negative 0.000000001 and positive 0.000000001. 0's not allowed to my party. Okay?
So because you had to use 0 and 7 more than once, is that what you did for the bracket?
Because the bracket says equals this. I don't want to equal 0. I want 0 to be excluded from my party.
Okay.
We can also do this in set builder notation, but that's a little more explicit. You would say all x's such that x does not equal 0 or 7, where x is an element of the reals. So you either use set builder to explicitly exclude things, or you use interval notation to cover the whole number line, but can't touch this. Okay, these two are not allowed. Either of those work. I'll tell you that the book always uses interval notation, and that's what I'm probably going to use moving forward, but you can use set builder, and it is still accurate. All right, B. What law is it going to break? Thou shalt not take even root of negatives, because I see a square root. So what numbers, or where's the dividing line between what's allowed and what's not allowed? I'm
Everything higher than 5.
okay, but how did you get 5?
Because if it's 5, it's
No, keep going. You're right.
because if it is 5, it would be 0, and that's
0 is the dividing line between negative numbers and not negative numbers. Right? Negative 0.00001 is still negative. But 0, what's the square root of 0? 0. I can do that. That's legal. Insert inappropriate joke here about ages and yeah.
Cool.
So, again, I'm going to set my radicand equal to 0 and say at 5. That is the youngest allowed at the party. Maybe you don't want them to get scared, or maybe you don't want them to run around hitting their brother because they watched the remake of Karate Kid. Okay? It happens. So, if 5 is the cutoff, am I allowed to be bigger or smaller? So I can say from 5 to infinity, or I can go to that set builder notation again and say all x's such that x is greater than or equal to 5. X is an element of the reals. Get out of the way. Now that doesn't look anything like an R, but I was fighting with Frank. So either of those is good. Again, the book is going to use interval notation. This is a cut-off problem. There you go. Now, what rules might I break?
1 and 2.
1 and 2. So I got to keep an eye on both of them. So step 1, I'm going to just deal with the radical first, before even worrying about it's on the denominator. I'm going to set the radical, or radicand, equal to 0, because that's always the cutoff line. Add 9, square root.
3 plus or minus.
I put the square root in, plus or minus 3. Okay, wait a second. There's 2 cutoffs? What does that mean? There's a whole range of them. If I look at a number line, here's -3, here's 3. I ask you the question, are numbers less than -3 allowed in? What if I put a -4 right here? Because -4 squared is positive 16. 16 minus 9 is 7. Square root of 7. Hey, that's legal. I feel like I'm just setting you all up for homecoming weekend, talking about what the rules are and whether it's legal or not. Okay. What if I picked something between there? What if I put 0 in? 0 minus 9. Square root of -9. I broke the second commandment. Okay. What if I put in something past 3? I put in 5. 25 minus 9, 16, square root of 16, perfectly legal. Okay? So that means the things that are allowed in here is everything before -3 and everything after +3. So I'll come over here and I'll write an incorrect answer of negative infinity to negative 3 union 3 to infinity. Why is it incorrect?
Just be a little circle ones instead of a square.
It can't be negative.
Well, if I put a 3 in here, 3 squared is 9, 9 minus 9 is 0, square root of 0 is legal,
But you can't divide by 0.
but I can't divide by 0, and that's what changes it. Is I can go all the way up to that 3. So to negative 3 parenthesis and 3 to infinity. Because I can't equal 3 itself, because then it would have broken the first commandment by dividing by 0. So domain is less about what can I do and more about what can't I do. Which as teenagers you should be just thrilled by. Because if you didn't explicitly say I can't do it, then I get to do it. Don't hit your brother. Throws sand at brother. These are the struggles. Or I could write that in set builder notation, all x is such that x is less than negative 3 or x is greater than 3, x element of the reals. So you get the choice. You can either do set builder or interval notation. They're both correct, but the book will use interval. Okay? All you're doing is looking at the function and saying, which of those laws am I about to break? Okay, those are the ones that aren't allowed. Which kid do I know is going to light something on fire in my bathroom?
That might
Don't let them in.
That might be.
Okay? Give it a whirl. Oh yeah, fire's amazing.
Oh, so you're the fire bathroom guy.
Your eyes
Not in the
lit
bathroom. Gotta be smarter than that.
Oh yeah, do it in front.
I was an only child on a farm in North Dakota where my nearest reasonably aged peer was a minimum of 6 miles and a four-wheeler away.
Do you have 3-wheelers?
I had a four-wheeler. My wife had three-wheelers.
Okay.
Three-wheelers are incredibly dangerous
Like, stop me.
because if you turn just a little bit too hard, yeah, that's not even a tuck and roll. That's you got handlebars sticking out of your guts. But anyway, do the problems. Who's not allowed to the party? Who's going to break the rules? Who's going to give your cat a string cheese bath? They're not allowed to the party.
Wait,
Exclude them.
a string cheese bath? How would you do that?
Warm cheese. Milk.
Why would you melt
Well, then you can't give the cat a bath if it's a solid.
Lars, do the problem.
My brain won't let me.
Hey, every kid that started twitching at our 3 variable systems not coming out perfectly, look at the magnification. Just for you. Frank's trying to make amends. It's 123%.
Okay.
It makes some kids happy.
Oh. You're right.
Perfect volume on the TV is 9 or 12.
No.
Yeah.
12 is way too loud.
I mean, it depends the game.
7 when we first wake up, 9 the rest of the day.
And then like, I feel like games. Then you get to like
Those are bad
movies.
mix.
It's like 20
Hmm?
just right.
7 and 9? No.
What deck is that?
Modern Burn.
Do you usually play Burn?
For expensive formats. For expensive formats.
It's kind of the best.
Because it's the cheapest deck. I'm a teacher, dude. They pay us in peanuts and insults.
Fair enough.
Melts your face off. If we make it past turn 3, I did something wrong. Burn. Attack a person's life total.
That's not
Really?
harder.
So it's like Pokemon.
It's getting worse than Pokemon.
There's no way.
What do you mean worse?
There's no way a Charizard is worth less than like a magic card.
There's one that's like.
Bro, there's some magic cards that are worth.
Last year, a Gem Mint 9.9 Alpha Black Lotus went for $680,000.
Oh,
Do you have that?
dollars?
God, no. I wouldn't be teaching.
Just about to say that. Yeah.
I would have, if I just randomly had a Gem Mint Black Lotus worth $680,000, I would have paid off my house, paid off all of our loans. I would have not taught last year or this. We would have moved out of the state.
Wait, where do you want to
Not this place. No. Okay. Anywhere that doesn't have a local legislation that is so far up its own that it tries to strip away people's human rights. So. Part A. What is that dude about to violate? Law number 1, thou shalt not divide by 0. So I take my denominator, set an equal to 0. Factoring is a thing. So if those are the two things that are going to make my denominator 0, then those are the two not allowed to the party. We say negative infinity all the way up to -4, can't touch us. And -4 to -3, still cool, but can't touch us. And -3 to infinity. You exclude the two who are going to break the rules. Okay. Mariah's looking a little sus. I'm going to make sure that she doesn't come to the party because she's probably going to try to flush something down the toilet that might blow up. Probably watched old 80s movies and saw Junior throw something down the cherry bomb down the school toilet.
I thought about doing that and leave. The seniors have a whole day.
Okay, round number 2. Again, thou shalt not take even root of negatives. So a squared -4 is 0, a squared is 4, a is plus or minus 2. Take a look at that number line and say, is it everything outside the 2's or in between the 2's that's allowed?
Outside.
Outside again. So we're going to say from negative infinity to -2, parenthesis or bracket? Because I am allowed to say -2. -2 squared is 4. 4 minus 4 is 0. Square root of 0, perfectly legal. So bracket, union, bracket, 2 to infinity. Contestant number 3. Well, I'm going to set that 2x plus 6 equal to 0 again. Okay, so negative 3 is the cutoff. Thou shalt not take even root of negatives. Are they allowed to be bigger than negative 3 or smaller than negative 3? You can always just test it, right? Just pick a 0 and put it in there. Okay? So if I put a 0 right here, I get a square root of 6 on denominator. I'd have to rationalize it, but it's legal. So it's everything that is greater than or equal to negative 3 is what's allowed in the radical, but not equal to, because then it would be a 0 on a denominator. So just greater than, which means negative 3 to infinity with a parenthesis. Okay? You getting the hang of interval notation? So we don't have to go to set builder? I hope. Set builder has its uses. But for most of the stuff we're going to do in here, we're probably sticking with interval. There you go. And I don't care which you use, unless I specify it in the instructions. Okay, piecewise. Right? Yeah, piecewise functions. Piecewise functions are really, really easy. They are not nearly as difficult as you think when you see a big honkin' chunk of letters and numbers. Piecewise functions are rules for portions of the domain. For example, if you're at mom's house, you will act this way. If you're at grandpa's house, you will act this way. If you're with your friends at Burger King, pickle races, okay, you'll act a different way. Pickle on the when, and then they slide down. You see who's hits the bottom first. Don't do that. Don't make them clean that up. You got to squiggle it in like the ketchup and mustard first. So, yeah. What this says is if I'm from 63 to 66 on the domain, follow this rule. If I'm 66 to 68 on the domain, follow that rule. If it's greater than 68, follow this rule. That's all it is. That's a piecewise function. A piecewise function states different function rules that apply to different parts of the domain. So if I say h of 67, which of those 3 domains is it in? So I will use this one. So what's that? 180, 21, 201, 30, 169? Question mark?
Isn't it 130?
It's 130. Minus
Oh! Yeah. Yep.
That's like technically. What is this?
That's like technically, be quiet. H of 72. H of 72. The last one. 2 by 72 minus 66. 144, 66, 84, 6, 78. Okay, that's all it is. That's a piecewise function. I define it for the different parts of the domain, follow the rules for that part of the domain. This is going to come to us again in 1-2 as we deal with graphing piecewise functions. Okay, speed of vehicle, miles per hour. Oh, hey, there it is. Do the thing. Which rule do you follow? Sent items. God, this is so slow. Oh wow, the stream is really lagged. I'm still standing over there. I'm still writing. Ew. My board no longer recognizes. All right. Part A. V is between 0 and 15, so we'll jam it in here. Say 4 by 5 is 20, 15. Oh, which one do I use? Because it says or equal to, so 4 by 15 is 60. And V of 245, that is between 240 and 250. Plug it in here. Negative 245 to 1200, 645, 240, 1440, 1480, 20?
30.
Oh, so close.
I would have said like random numbers so you guys
Okay. All right, we got it.
That was the easiest thing we've done all day.
Come on, Frank. Where are you? There you go. All right. Save that for the weekend too. 1, 2, because we've got so much stuff to do. Because y'all love graphing, right? Which means that you have put your due diligence towards learning about graphs and analyzing them in detail in the past, right? That's why we have to spend some time on graphs, because we got to know how they work quite intimately. In fact, that's what sections, all of chapter 1 is analyze the bejesus out of graphs. Chapter 2 is, okay, now do that with all these different types of functions. So, trip down memory lane, if I got a graph, what is the this and the this called? X and Y axes. Okay. The axes are labeled for a reason. Reading the problem explains the problem. Years since 1998, so when I see a 6, that's not the year 6. When is it? 2004. Okay? So, off to the side, that is not 3,000. That is not 4,000. What is it?
It's not
3,000 millions.
Like, I don't like
3 billion. Okay?
Yeah, why can't they just say billion?
Because Below 1 billion are the hundreds of millions.
So that's still easier. I would have just preferred 1, 2, 3, 4, 5.
Would you have rather said 300 million or 0.3 billion? Okay, that's why they have it labeled this way. So, use the graph, estimate total internet advertising revenue in 2007. Confirm algebraically. So first of all, guesstimate. Where's the year 2007 on there? Okay, 9 years after 1998. So we head over to 9, dot, 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 up to here. We come over here and we say about. So we're, well, okay, what is this? That's 3.5. So what's that?
3.35. That's what I said.
3.33.
Maybe 3.5, 3.4 I heard. Let's do 3.4 instead of being too weird with it. Now it does say confirm algebraically. And this is the point in the year when I remember that there's an equation with this on the first page of section 1-2 in your book, and I forgot to put it in here, and every year I forget to change the notes to include it. So, who's got a book? Yeah, you shouldn't have to. Okay. Book, section 1-2. That's not 1-2.
Don't say that about yourself.
I know.
I said I was there.
Okay, right there. Read that off for me.
The whole paragraph?
So it's
Oh, R.
year revenue in terms of time is 17.17?
7.
17.7
T cubed. Minus 269 T squared plus 1,458 T minus 910.
Okay. So there's an actual function that goes with this. So when they said estimate and confirm algebraically, how will I confirm algebraically? Plug what in? Plug in 9. We are estimating the revenue in 2007. 2007 is 9 years after 1998. So plug a 9 in here. I'm not going to do it on my calculator because Frank sucks. You do it.
Can we write this in our notepad?
Yeah. So now you're going to say R of 9, and you're actually going to give me the value. Now remember, the function is written in millions of dollars. So your answer should come out as not 3.4 billion with a crap ton of zeros. It should come out as about 3,300, 3,400. $3.3326. Mother of God, it was actually 3.33 billion.
Ha!
we don't like to tell Lars he's right, but yes, that
Woo!
nailed it.
I said 3.35.
All right, down at the bottom. Ah, crud. Use the graph to estimate the year in which the total internet advertising revenue reached 2 billion. Again, if you're not paying attention to the side, if you're not looking at the scale, you might wonder, why are they saying something billions here?
Don't forget the 9, 10.
Oh. God, Frank, I really despise you right now. So I go to 2 billion over here, down here. I say it's about the year 6, 2004. So I'm going to say about 2004. What is 2004, or 6 years after 1998? So we're saying that 6, 2000 should be, right? 2 billion? Okay. We're saying that should be a coordinate that exists on this graph. Check algebraically. I have the choice of either putting in 2000, carrying it over to the other side and solving, or plug in 6 and hope it comes up real close to 2000. Okay. Now, some of you were a little sketchy on how to use your calculators. I closed this, didn't I?
Pretty close, but it's not exactly. Like 23.
I would like everyone to input that function into Y1 in the graphing calculator. I want to make sure that everyone knows how to do this. Come on, go faster. My God, you're so slow.
So I was trying to get to my math book from my computer and like the internet was yeah.
And the thing is, the district's made a really big monetary investment in getting a couple, 1,000 new laptops. So the idea that they would just replace them, unless they can prove that there's a system-wide issue to their distributor and get a refund and then re-image 1,000 new laptops, we're just stuck with these, at least for this year. Minus 269 x squared plus 1458. 58 x minus 910. Okay. All right. If I plug this in, we have choices. We want to know when this is 2000, right? 2 billion, but 2000 on the graph. First of all, if I try to graph it right now, I have never seen a computer be this slow in class. Ever. No. I have one of the old laptops over there for Game Club to watch YouTube videos. I'm going to use the old laptop instead and throw this over there because screw this piece of... All right, tomorrow this should work. And go back to the ancient technology. Right now, I just see what looks like a straight line. That's because this looks nothing like this.
You have to change your window.
And if I want to know what to change my window to, look at the graph, right? go out to at least 10, go up to at least 5,000, and it should give you the exact same graph. So I can manually change my window. Say we're going to go from 0 to 10, go by ones. Come on, Frank. We're going to go from 0 to 5,000. What were each of their boxes going by? 500s? I heard someone say it, and just right. They only wrote every 1,000, but each box was 500. So if I do this, I should have the graph identical to what is on my paper. I have never seen it this slow before.
Normally it looks like so cool and smooth.
All right, I'll show you all another little cute feature on here that you may or may not have seen in Algebra 2. If you're on an 84, if you're on an 83, sorry, but if you're on an 84, and you come right above Zoom as format, I can turn my grid on. So now it'll show up exactly like my graph on the page because now it'll have the boxes. Okay?
That's cool.
Okay. And those lines are going to appear wherever you set your scale. So if you just didn't change the scale and you left it at 1, it'll just be a blur of gray because of all of the lines. Okay? So if I want to know when this hits 2,000, there are two options. Option 1, I'm able to set the function equal to 2,000, solve. Option 2, on a calculatron, I want to know when the y is 2,000. Please tell me you remember this from Algebra 2. Head down to y2, plug in 2,000. Graph. Because now it puts in a second function at y equals 2,000. And right above trace is calculate things on the graph screen, like an intersection. It's going to ask me, which curve do you want? I need to make sure it's on the first function. Which curve do you want? Make sure it's on the second function. It's going to ask you for a guess. I say, I don't care. Just tell me the answer. So I hit enter again. And it tells me at exactly 6 point and some change. So it wasn't 6 exactly. It was in the year 2004. But now I could do unit analysis and use that decimal train to tell you exactly when.
Do it. Right now.
How? Point. What's that? 152, 343, 9. Second quit. Point. 152, 343. I'm trying to do everything sideways here. 343, 9.
It's 1524.
Oh, 434. 4?
4349.
Okay, so I just swapped my numbers. Okay. If I take that times, let's get even spicier on it. 2004, was it a leap year or not?
Yes.
How do you know?
Because every 2020 was yeah.
100 is divisible by 4. Every 100 years is a leap year. So then anything divisible by 4 is also a leap year. So I'm going to take that times 366 days. So it's that many days into 2004. So if I take away January, On February 24th, 2004. That much of that day times 24 hours. 18th hour, that's 6 p.m.
Bro, it's weird.
Times 60 minutes in an hour. Y'all remember physical science?
No.
Unit analysis. It's going to come back to us in chapter 4.
We were in Rome.
So, February 24th, 2004 at 6:59 p.m. is when this will happen. Well, yeah, subtract 59 times 60. That'll get you your seconds. You keep going. Unit analysis. Now, do you have to do this? No. You just confirmed that it was in 2004. I'm showing you that you can because it is a very common application in other classes. So,
I just forgot all of that. So.
I know I did have a kid go down to the milliseconds before in a class just because he felt like it and he was trying to show off, but he was kind of a kid that liked to show off anyway.
So we don't like kids like that. I'm just kidding.
I won't name names. I'll just say
Why'd you look at me?
they were pedantic and graduated last year.
Was their last name Sailor?
So we have another question where you're going to do the exact same thing. Can you analyze the graph? I think you can do it a lot faster than I can fighting with Frank. So just finish this off. We've got time. We've got 5 minutes. Type it in, do the things, press the buttons. Okay? And I really am sorry about Frank being a royal piece right now. Because...
Maddie and I can get in a fight. We'll fight and then just like throw each other.
That's not what they did it with Aspen and geometry.
Hey, we don't need to talk about what Aspen and I did in geometry.
Okay. If you're going to use that intersection feature again, just make sure that when you're moving Blinky around on the graph, have it close to the intersection you want. Like, you can't put Blinky on the far left and the far right side of the graph and give you all of the intersections. You have to do them individually. That's actually a really good book. Running with Scissors. Running with Scissors is a coming-of-age story of a guy discovering his own mental health in a house full of genuinely bat-crap crazy people. Yeah.
Crazy people.
Yeah, it's a very interesting book. It's very graphic, but very interesting.
So do you use this equation when it doesn't give you one?
No, they gave us an
No,
equation on
I'm
here.
just saying like this one. We use that.
Oh, no, that was specifically for this. It was written in the text above this problem in the book. I just forgot to put it on the page.
They updated that calculator app on the phone last year. The thing I use all the time.
The iPhone one?
Yeah.
Does it do other regression finally?
I haven't checked it.
Could you send me what that app is? Because I forgot what it
It just
was.
has the one variable, two variable, linear, and just the linears.
Okay. Still, I can use that for Algebra 2. If you
You can graph.
just send me on Remind what that was. I forgot what it was, and I also nuked Remind. So, yeah, I kind of wanted to make last year not exist.
Yeah, you deleted like the entire social media, like everything.
Yes.
Why?
Because it was without even the slightest exception the worst year of my career.
Cool.
Worst of mental health since I was a teenager.
We go into Q
Like, it was bad. Like, I didn't like me last year. Okay. Okay. When you plug this in, estimate on the 10th day. I'm betting it's going to be 31-ish. Oh, 32. What is it, like 32 on the nose?
Yeah.
Oh, cool. Okay, so value of it is $32 a share. Down that, when is it valued at 30? So again, you're going to say Y1 is this. Y2 is 30. It's going to put a line right here. And you're going to find this intersection, and this intersection. Oh, yeah. Because look it up here. The y-intercept of this function is 31. That means it started at 31 at the beginning of this. So on that first day, on day 0 point something, it was $30 because it started going down from there. So, did you change your window? Oh. Right. Oh. Did anyone have a graph that just looked like a straight line and not this? You know that minus is not negative button on your calculator? So if you use the negative button in place of subtract, it will take this times this plus this times this. You'll end up with a, was that heptic or septic? Heptic. Well, hept and sept are both Latin prefix for 7. We just tend to not use septic. But your homework will be the second half of 1-1. I don't know if I'll put anything from 1-2 on there. It would just be the first example. I got to get the daily quiz and crap for next hour done. And I was fighting with Frank this morning, so I didn't get it done. Because, Frank!